Okay, so we have to do a bit of vocab to start here for 10.4. The first vocab word that we want to talk about is a secant. So a secant line is a line that intersects the circle in exactly two places. So this is a line. So sometimes I talk about a secant segment, which might be from one of those points of intersection out to another point on that line. I can really choose any secant segment I want. If I choose just the interior part of that secant segment, what I have is a chord. So the other vocab word that we want to talk about is a tangent segment, or a tangent line. So a tangent line is a line that intersects the circle in exactly one place. So in order to draw a tangent line, I have to just skim the edge of that circle. So there's only one intersection here, and we call this the point of tangency. Again, I can talk about a tangent segment if I like. That would go from that point of tangency to some other point on that line. So this would just be a tangent segment. Okay, so if we have two circles that are internally tangent, then we are going to draw one circle and then a smaller circle. Oops, that was a poor drawing. This circle right here. So this is the one place that those two circles intersect. If two circles are externally tangent, the same idea is true. They only intersect in one point, but they're outside each other. So there's one point of intersection in there. If two circles are concentric, then it just means they have the same center. So here's the center. I could have one circle around it there with a radius of, 1. And then another circle that has a larger radius. And finally, if two circles are disjoint, then it just means they don't intersect at all. Okay, so the last bit of vocab is a common internal tangent segment. So in order to have a common internal tangent segment, we have to have two circles that are disjoint. So the internal tangent segment goes in between what would connect the circle's centers. So if I thought of this as a dotted line connecting the circle's centers, then the internal tangent segment goes through that, and it meets at one point of tangency up top, and then one point of tangency down here. The common external tangent segment, I can start with either circles that are disjoint or circles that are tangent. And this connects the outer parts of the circle. Okay, so finally we have a postulate. This says that if you have a tangent line, so if there is a tangent line, there is a tangent line, then the radius drawn to that point of tangency is perpendicular to the tangent line. So all this is saying is that if I take a radius and I draw that radius out to that point of tangency, then I know that this must be a right angle. And the converse is true as well. So if I have a right angle, So if you have a right angle between a line and the radius, if there is a right angle between a line and a radius, then that line must be tangent to the circle. Okay, and the last theorem that we have is called the two-tangent theorem. So this says if I have two tangent segments here, so let's call them AB and BC. So if you have two tangent segments that connect to a single point outside the circle, so if there are two tangent segments that connect to a common point, then those two tangent segments are congruent. So in this case, AB is congruent to BC. And you could prove this if you want to. I'm not going to go through the whole thing, but you can imagine looking at those two triangles. Perhaps you could prove triangle AOB congruent to triangle COB. And I'll leave that exercise to you.